Lesson 6.4, Graphing Inequalities. Just a quick review on our inequalities. You guys all know these. The first one here is a less than sign. The next one is, of course, less than or equal to. Then we've got a greater than sign. And finally, we've got greater than or equal to. All right, we're going to be graphing inequalities today, as you can see, right? We've got our XY planes. The signs themselves tell us two things. It tells us what kind of line we're going to draw and also where to shade. And we get all of that from just what kind of sign has been used. All right, so here is the breakdown, and we are going to practice this, so don't worry about if you feel like you're not going to remember it. When we've got a less than sign or a greater than sign, our lines will be dashed instead of solid. Okay, again, less than or greater than signs. You guys might notice that if we're missing the or equal to part, it's going to be a dashed line that we're going to graph. All right, if we have the or equal to part, right, the greater than or equal to, less than or equal to, it's going to be a solid line. All right. The last column is telling us where to shade. You guys could probably guess at what we're going to do for this. Our less than signs, whether or not the or equal to part is there, we'll shade below the line. Right? Less than, below, you get it. If we've got a greater than or equal to sign, where do you think we're going to shade? Yep, above the line. Now, this probably makes no sense at this moment, so let's go ahead and look at an example. Problem number 1. We've got this inequality here, but it's still a linear function, so we still have to graph what we would normally graph for a line. So let's identify our slope, m, that's going to be a 2, and our y-intercept is 3. All right, so we're going to draw our line using the slope and the y-intercept. Here's the y-intercept at 3. My slope is 2, so I'm going to go up 2 over 1. Up 2 over 1, up 2 over 1, and I'm going to draw my line. Oops, I drew the wrong line. Look at that. Should have paid attention. Guys, I should have filled in what kind of line this was going to be first, because a less than sign actually tells me the line itself is going to be a dashed line. Okay, it's going to be a dashed line. If there had been a or equal to symbol, I would have been fine with a solid line, but no, a dashed line here. So go ahead and let's draw some more points. I feel like that just makes it easier because I can't really use a ruler on the iPad here. And we're going to draw a dashed line here. Okay, now the fact that it is a less than means we're going to shade below this line. So start on a line and go down. Go down, go down, go down, go down. This entire portion of the graph, okay, this entire portion of the graph is going to be shaded. Everything that is below the line, right? You can shade this with your pencil, you can draw little squiggles, whatever, but like you need to know that every single thing below this line, every point below this line is part of your solution now. All right, let's take a look at problem 2. In problem 2, our slope is 1/2. Our y-intercept is -8. I do have the or equal to line under that inequality, so I'm going to have a solid line this time. And because it's a greater than or equal to, this time we'll shade above. So first things first, let's get some points on our graph. My y-intercept is at -8. And my slope is 1/2. So up 1 over 2, up 1 over 2, up 1 over 2. Draw your line. Oops. Draw your line here. There we go. Solid this time. And we're going to shade above the line. So everything on this side of the line gets shaded. Guys, if you're not shading, you're doing it wrong. Okay, you cannot just draw the line. It is not the same as the inequalities that we had been practicing earlier. Okay, you have to shade. All right. Problem 3. Oh, you know what? I forgot to check points. So we've got these questions under our graphs here, and we're just given random points, guys. These points don't have any significance except they're just asking us to check them. All right. Is 1, 5 in the solution set? Well, here's 1, 5. Oh, you know what? It's on the line. This is actually not part of our solution set. And the reason is because it is on a dashed line. Okay, just like the symbol itself, like it's less than, it's not less than or equal to. So if it's on a dashed line, we actually do not include those points. The next graph is giving us a random point to check. Is 0, 1 in the solution set? Well, here's 0, 1. It's in a portion that has been shaded. So yes, it is a solution. I'm going to say in the shaded region. That's how I know. All right, now example number 3. Here we go. All right, we've got a slope of -1/4 and a y-intercept of 5. Due to my inequality, I know that my line will be solid, right? It's got that or equal to line. And I'm going to shade below because it's a less than sign. Let's get some points on the graph. We're going to start at 5. My slope is -1/4, so I'm going to go down 1, right 4, down 1, right 4. I'm going to draw my solid line, which is a little easier for me with my technology here. All right, and I'm going to shade below this line. So from the line, go down. Anything on this side of the graph of the inequality is part of your solution set. So you need to shade everything under that line. All right. Again, if you're not shading, you're doing it wrong. You have to shade for inequalities. And we're asked to check the point 1, 1. Is 1, 1 in the solution set? Let's change the color here. Okay, is 1, 1 in the solution set? Well, the point 1, 1 is here, and it has been shaded. So, yes, right? It's in the shaded region. Okay, here we go. We've got one last graph to do, and this one is a little bit tricky. You'll notice that we don't have a normal slope-intercept inequality, right? Y equals mx plus b. We just have x. So if you'll recall, our slope and our y-intercept are a little bit strange. Our slope, because there's no y equals or y, at all, is actually going to be undefined. And our y-intercept, we're going to write none, right? Because when we have x like this, it's going to be a vertical line. You may have heard the phrase hoi vux, right? Vux, VWX, sorry, VUX, vertical undefined slope, x equals, or in this case, x is less than. The line is still, we're just still looking at the inequality to decide the next part. It's going to be a dashed line, and we're going to shade. Since it's the less than sign, I'm going to write below, but we're going to kind of talk about why this doesn't make perfect sense in this example and how to kind of figure it out. So, vertical line where x equals 2. Well, here's where x equals 2, right? This right here is going to be where my dashed line goes, because on this dashed line, all the x values are 2's. All right, all the x values are 2's. Now, there's no such, I'm not going to shade down here for below. That makes no sense. I need to shade either this side or possibly this side of my line. Well, it's telling me to shade below, but in this case, it doesn't really make sense. So just think about it. Where are x's less than 2? Right? Would you go left from 2, or would you go right from 2 if you wanted them to be less? Okay, well, x's get smaller this direction, right? So this right here is where x's are less than 2. So because this is a vertical line, we're actually not going to shade below, because it doesn't really work in this example. We get to shade to the left. I'm going to say to the left in this example. All right, and we just got to check a point to be finished. Is 2, 3 in the solution set? Well, let's see, 2, 3 is right here. I'm going to say no on a dashed line. All right, just for kicks, why don't we try one more? What if I try the point 8, I don't know, 5? Is 8, 5 in the solution set? Well, 8, 5 would be right here. We would say no. This one is not in the shaded region. So if you guys are asked to check points, remember, just plot them. If it's in a shaded region, it's a solution. Non-shaded region, not a solution. All right? When you're graphing inequalities, remember the most important thing to do is to look at the inequality. It's going to tell you what kind of line and also where to draw it.